Alright, this video is going to be about our combined gas law. So we're going to go under that tab, and we are going to talk about the combined gas law. So first, let's remind ourselves of what all we're working with here. So combined gas law means we're going to use all three variables. So our pressure, which is our number of collisions, our volume, which is our space, and our temperature, which is our speed. Pressure versus volume is inverse. Pressure versus temperature is direct. Volume versus temperature is direct. And we want to make sure that we change our degrees Celsius to Kelvin. So all of those are rules that we've already talked about, definitions we've already talked about, but now we are going to be putting them all together in one problem. So let's go ahead and take a look at that problem that is on the left side there. And I'm going to start just like I usually start by underlining the information that's important. So a sample of carbon dioxide has a volume of 34 liters and a temperature of 35 degrees Celsius and a pressure of 2 atm. So right there we already see the difference in that we have three different variables that we're working with. If the sample decreases in volume to 28 liters and increases the temperature to 45 degrees Celsius, what's the new pressure of the gas? Then it asks what will the pressure be in millimeters of mercury. So we're going to start the same way. P1, V1, T1. So notice now I have three variables for each of my little groups. P2, V2, T2. So 34 liters. Liters is volume. 35 degrees Celsius, so I need to add there. It's me 308. Both of our ones places are significant, so I can keep to my ones place there. 2.0 atm. Don't forget that 0. It's significant, so we want to make sure we keep it on there. V2 is going to be 28 liters. 45 degrees Celsius. Again, we need to change that. It's us 318 Kelvin. Once again, our ones places are both significant, so I can keep to my ones place there. And I'm looking for this new pressure. And then I'm going to put myself a reminder here that I want it in millimeters of mercury. So let's go ahead and make our table. This time we have three parts to our table. So we're still going to follow the same method. So we're going to look and see which group has all of its numbers. So group 1 has numbers for all three variables. So we're going to put group 1 in the table first. So 2.0, 34 liters, and 308 Kelvin. Don't know my new pressure. It's what I'm looking for. 28 liters and 318 Kelvin. Now this time I have two variables that already have both numbers, so I'm going to go ahead and draw my arrows for both of those. So volume going from 34 to 28 decreased, and temperature going from 308 to 318 increased. So that is based on the numbers that we have. I'm going to make what I call a mini chart or a mini table right here. I'm looking for pressure, so I'm going to have to compare pressure to both volume and temperature. So this part we're going to pretend like it's just two variables. So I'm going to cover temperature up, and I'm going to say as volume decreases, what happens to pressure? Well, we just said that they were opposite, so as volume decreases, pressure in relation to volume is going to increase. Then I'm going to cover volume up. Temperature increases, what happens to pressure? It increases. So pressure related to temperature increases. So now I'm looking at two arrows here. Now setting up our math problem is going to look very similar. So I'm going to go ahead and put my number that's with my x. So I have 2.0. This time I'm going to have two fractions. So my volume arrow is pointing up, so that means my larger number from volume needs to go on the top. So 34 arrow in relation to temperature is pointing up. So my temperature number, the larger one, needs to go on top. We're going to put that in our calculator, and we get 2.50742115. Now we need to look at sig figs here. I have 2, 2, 3, 2, 3. So I can only have 2 in my answer, so 1, 2. What does that 0 do to that 5? Nothing. So 2.5. And right now we're in atmosphere, so ATM. So that answers this first part, what's the new pressure? But I put myself a reminder here that it also wants to know what the new pressure is in mmHg. So let's look at doing that conversion. Now remember, this is when we used our dimensional analysis. So I have 2.5 ATM. I have ATM up here, so I need ATM down here. And I'm going to millimeters of mercury. So if we flip back to the tab for pressure and temperature conversions, we can see that the number in front of ATM is 1. The number in front of ATM right here needs to be 1. And for millimeters of mercury, it is 760. So 760. Multiply across, divide down, and I get 1,900. Our conversion factors here do not count into our sig fig, so only this, which we just said was 2. I have 1, 2 here, so I'm good with that. So millimeters of mercury. So that would be our final answers there. So this was putting all 3 variables together, working that out, and then converting. So let's go ahead and look at our next example here. A sample of an unknown gas has a volume of 48 liters at a pressure of 1.2 atm and a temperature of 312 K. If the pressure increases to 1.80 and the temperature increases to 325, what's the new volume? So just like we did before, we're going to do our variables. So P1, V1, T1, P2, V2, T2, 48 liters. That's my volume there. 1.2 atm. That's my pressure. And 320 Kelvin. We're already in Kelvin, so we're good to go there. If the pressure increases to 1.80 atm, don't leave that 0 off. It's significant. 325 K. What is my new volume? We're going to go ahead and make our table here. Group 1 already has all of its numbers, so we're going to do group 1 in here first. Then we'll put in group 2. Oops. Wrote 1.80 twice. Sorry about that. I wrote 1.80 twice for some reason. So 320, then 325. So now let's look at our arrows. So our pressure increased. Our temperature increased. So let's make our mini chart here. We've got pressure and temperature. I'm going to cover up temperature. As pressure increases, volume decreases. As temperature increases, volume increases. Okay. Now we're looking at the arrows with our X here. I'm going to write my number that's by itself there with the X. Now my pressure arrow, volume in relation to pressure, is pointing down. So my larger number for pressure is going to have to go on the bottom. My volume in relation to temperature is increasing, so my larger number needs to go on the top. We're going to put that in our calculator, and we get 32.5. Now let's talk sig figs here. I have 2, 2, 2, 3, 3. So I can have 2 sig figs in my answer. So 1, 2. I say, what does that 5 do to that 2? Makes it a 3. Then I'm looking for volume here, so I need to watch, and it needs to be liters. Okay. So there was no converting of anything that had to happen in there, temperature or pressure. It was all ready for us to go and use it. So let's check out our next one here, where we will have to change our temperature. I need to know what the temperature of a gas will be, so I'm looking for temperature. If I decrease the volume of the gas to 4.2 liters and decrease the pressure to 5 atm. I start with 7.5 liters of gas at a pressure of 4.0 and a temperature of 50 degrees Celsius. So I'm going to go ahead and write my variables down. So I'm working with all 3 of them again. I'm looking for my temperature, so I'm going to put an X right here. When I'm doing that, I have a volume of 4.2 liters and 5.0 atm. When I started out with this gas, my volume was 7.5 liters at a pressure of 4.0 atm and a temperature of 50.0 degrees Celsius. Now I have to add my 273 there. So that gets me 323. This 0 is significant, that 3 is significant, so I can keep that ones place. There's no decimal here, so I cannot keep the decimal. Ready to go ahead and put it in our table. Now I'm going to put the group that already has all of its numbers in there first, so that's going to be group 2 here. So we've got 4.0, 7.5 liters, and 323 Kelvin. Then we have 5.0 atmospheres, 4.2 liters, and we're looking for our new temperature. So pressure went from 4 to 5. It's an increase. Volume went from 7.5 to 4.2. It's a decrease. So now for temperature, I need to make my little mini chart. Temperature in relation to pressure is going to increase. Pressure increases, temperature increases. Temperature in relation to volume, volume decreases, temperature decreases. So these are the arrows we're working with here. Let's go ahead and set up our math problem. My pressure arrow is pointing up, so my larger number needs to go on top from pressure. And my volume arrow is pointing down, so my larger number needs to go on the bottom there. Put that in our calculator, and we get 461.42857. We need a sig fig, so we have 2, 2, 2, 2, and 3. So I can only have 2 in my answer, so 1, 2. So that will give us 460 Kelvin. Now if they wanted this in Celsius, we could subtract 273 here, which would give us 187, but we cannot have a significant digit in that 0 place, or in that ones place, I mean, because of the 0. So we would have to round that to 190. So you could have 460 or 190 there. So that is another look at the combined gas laws. So remember, combined gas laws where we're putting all 3 of them together. You may have to do temperature conversions. You may have to do pressure conversions. You may have to do metric conversions. Say that this was in liters and I needed this one in milliliters. So just be conscientious about what the problem is asking you and what variables you have.